There's a lot of changes coming to the electricity grid. We're now seeing a broader penetration of things like solar panels on people's homes, electric vehicles in people's garages. That requires the ability to bring power back into the system, not just taking it off at your home. Today, the grid is not set up to do that, but technology exists and it's beginning to be deployed that will help build this super grid of the future. Investment in the electricity grid in the U.S. is about $50 billion a year. There's about $25 billion lost in economic value due to the loss of electricity. A distribution substation, which is the connection point from where power at high voltage comes to lower voltage and comes to your home. Each of these installations typically have 100% redundancy of all the equipment in it. They're built for worst case. Today, the way that the grid deals with reliability is it segments each part of the grid into a distinct neighborhood. It allows for that neighborhood to be able to lose power, and then service people are then deployed to be able to bring that part of the system back up. The U.S. system, from a reliability standpoint, I think is ranked maybe in the top 20 globally. We believe that there's a different future of a supergrid, being able to interconnect different nodes on the network, like you would for transportation, like you would for communications or computing. One of the enabling technologies for this is something called high temperature superconductors. This is technology that won a Nobel Prize back in the late 1980s. It's technology that's being deployed today into the surface fleet of the U.S. Navy to protect ships. And we believe that we're beginning to see the advent of proliferation of this technology to protect the grid. How the technology works is you have material that allows for the free flow of electricity at very high quantities with very little loss, meaning that the power you generate on one end or you want to move from one end to the other, you don't lose that power along the way. You're also able to do it in about 1/10 of the right-of-way. So the land that you need to require or the access under the city streets, you're now in a format that's amenable to thinking about putting pipes between assets on one part of a city to another part of a city. It's like the Internet of Power. Multi-connection to multi-points throughout the system means you're going to have greater reliability.